Hello and welcome back to MathsBytes. This is video 7 in the binary numbers series, and we will talk more about how to convert binary numbers to decimal numbers. But this time I will show you a shortcut version from the place value table method we learned in the last video. I will again show you a few examples, then you will have a chance to do some practice questions, and we will also come up with some sort of step-by-step instruction on algorithm for converting binary numbers to decimal numbers. So you will have a go-to process to do these calculations with ease and efficiency. First, I would like us to remind ourselves how to convert binary numbers to decimal numbers using the place value table. Can you please spend a few minutes trying to write down how you would convert a binary number to a decimal number? First, you copy down the binary number place value table, then you place the binary number into it, making sure the rightmost digit of the binary number is at the smallest place value of 1 in the table. This is a kind of backwards copy of the number in the sense that you are writing the number into the table from right to left, opposed to the normal way of writing the number from left to right. Once the number is in the table correctly, then we write out the digit and place value multiples, usually using both the index and decimal values of the place values. Finally, we add them together, and if we cannot use the calculator, you can add up the numbers in pairs that are easier to sum, such as 2 and 8 or 64 and 16 using chunking. I hope you have written something similar. I'm sure yours is different, but as long as your description had captured the same essence, you are good. Remember, I have been teaching this for over 15 years. Do not compare yourself to me. Your aim is to be 10% better than you were in the past. Steady, small progress on a regular basis will make a massive difference in the long run. Just don't stop wanting to be better, and I'm confident you could reach your goals in life. Now you know how binary to decimal conversion works using the place value table, and this is a perfectly sound way of doing the conversions every time. However, you could ask if we could make some shortcuts and make the whole process faster. Let us try just that by summarizing some observations first. When doing the final sum, every place value that had a 0 underneath was skipped, as 0 times anything is always 0, so we don't really have to write them out. Next, the place values with 1 are the only place values that will contribute to the sum, and they will only contribute their values once, as anything multiplied by 1 is itself. So we can just sum up the place values with 1 under them. Now, is there a trick for doing away with the place value table? After all, writing up the place value table is quite time consuming without the help of animation. We spotted in the binary place value table video, which is video 5, that when moving along the place values from right to left, each place value gets doubled. So we could just write the place values above the individual digits, starting with 1, placed on top of the rightmost digit, and from then on, doubling at every move from place value to place value. Let us see how we could apply these tricks and shortcuts in practice and convert the following binary numbers to decimal. First, we write the place values on top of our numbers, the first of which is 1, 1, 0, 1, 1. So, the smallest place value of 1 will go on to the top of the rightmost digit, which is 1 in our case. The next place value, 1 place to the left, is 2, the next is 4, the next is 8, and the highest place value for this number is 16. So far, we have saved quite a bit of time not having to write out the whole place value table and stopping exactly where we run out of digits in our binary number. Next, we will write down the place values that have a 1 under them, since they are the only ones that matter and they only count once. Again, remembering that anything multiplied by 0 is 0, hence these are not contributing to the overall value of the number. So we get 16 plus 8 plus 2 plus 1. We add 8 and 2 together to get 10, then add 16 to it to get 26, and make sure we don't forget to add the 1. So the final answer is 27. Therefore, we can write the answer as 11011 in binary equal to 27 in decimal. Remember, we have to use the letter 2 and 10 in the bottom right indexes to clarify that one of the numbers is binary and the other is decimal. After all, 11,011 is not equal to 27. So without the index notation, this equality would be mathematically incorrect. I hope you agree with me that this method is quite a bit faster, especially if you just do the calculations and don't have to explain every step. Let us look at the second example. 111011. Again, we will start with writing the place values on top of our number, starting with the rightmost digit and placing a 1 there. After this, we will move to left one by one and place double of the previous place value on top of the next digit, such as 2, 4, 8, 16, and finally 32. Then we pick out the place values with a 1 under them, which are 32, 16, 8, 2, and 1. Then we just have to add them up. 32 add 8 makes 40, 16 add 2 and 1 makes 19. So the final sum is 40 add 19, which is 59. All is left now to write out the answer neatly. 111011 in binary is equal to 59 in decimal. Our next number is 1010110. Start by placing a 1 on top of the rightmost digit, which is 0 in this number. Then double this place value to 2 when moving 1 across to the left. The next place value will be the double of 2, which is 4, and place this above the next digit to the left. Next is the double of 4, which is 8, next is 16, next is 32, and the last is 64. Now that we have the place values, all we need to do is to pick out the place values that have a 1 under them and sum those up. In this example, these will be 64, 16, 4, and 2. We pair up 64 and 16 again, that will add up to 80, and then add on the 4 and the 2, which altogether will make 86. So 1010110 in binary is equal to 86 in decimal. The next example is 11001101. I hope you get the drill by now, so let us go ahead and place the place values on top of our digits, starting with 1 above the rightmost digit, then doubling all the way up to 128. Then pick out the place values with a 1 under them and add those up. The sum will be 128 plus 64 plus 8 plus 4 plus 1. This is not the simplest addition to do, unfortunately. There are no nice number bonds that could make our life easier, so we just have to bite the bullet and do the calculations. However, I will use chunking, adding tens and units together to ease the pain of this sum. Let's get to it. 128 add 64 can be done simpler if we first add 120 and 60 to 180, then add 8 and 4 to 12. Finally, add 180 and 12 to get 192. Now we have the two largest numbers out of our way. Let's move on to the smaller ones. 8 plus 4 plus 1 makes 13. All that is left now to add 13 and 192. First, we will add 190 and 10 to get 200. 3 and 2 makes 5, which altogether makes 205. So, 11001101 in binary is equal to 205 in decimal. Again, the letter 2 and the letter 10 in the bottom right corner serves a very important purpose to identify that one of the numbers is binary and the other is decimal. We have one more example, 1100111001. Then it will be your turn to practice this binary to decimal conversion on your own. Again, copy down our binary number of 11001101 and start writing the place values on top of the digits, starting with 1 above the rightmost digit and doubling the place values one by one all the way to 256. One more tip. When you are writing binary numbers, you will notice that the place values get to multiple digits pretty fast, and you will not necessarily have enough space above your digit for the higher place values. To avoid this problem, try to space out your binary number a little more than you would normally do. This will help you keeping things clear and not confusing which place value belongs to which digit. If you don't like spacing out your numbers, you can try writing the place values vertically too, such as this. Having the place values vertically will take some time to get used to, but if this helps you, go ahead. If you can come up with a different way to make the place values easier to write on top of the digits, share it with others by commenting below. Now, let us copy down the place values that have a 1 underneath them and sum them up. 256 plus 128 plus 16 plus 8 plus 1. Unfortunately, in this sum, we don't have any number buttons of 10, so we have to do good old-fashioned addition like in the previous example. I will still add 2 numbers at a time, which is easier to do. 8 and 1 makes 9, then adding 16 to this will make 25. Then, when adding 25 and 128, I first add 20 to 128 to get 148, then add 5 to it to get 153. And finally, we can add up 153 and 256. I will do chunking again. First adding the hundreds, then the tens, and finally the units. So 200 and 100 makes 300. 50 and 50 makes another 100. So in total, we now have 400. Lastly, we can add 3 and 6 together to get 9. Therefore, our final sum is 409. We can then write down that 1100110001 in binary is equal to 409 in decimal. Let us summarize what we do in this new shorter method. We first place the place values on top of our digits, starting with the rightmost digit and place value 1. Then we keep doubling the place values by moving one place to the left until we have the place values for every digit. Next, we copy down the place values with a 1 under them, and finally we add these together. Now you might ask me, why didn't I start with this method in the first place? I believe if I just showed you this method right at the beginning, we would have missed out on why and how this works, and you could risk copying a method you don't fully understand, and when we don't fully understand why a method works, we are prone to mistakes. I hope you don't mind me wanting to ensure you understand all the methods I will show you. Now I think you have been sitting on the sideline for long enough, and by now you are hopefully very eager to get involved. Remember, maths is not a spectator sport. You have to try things out and often make mistakes to learn. So here are a few binary numbers for you to try to convert to decimal numbers. Pause the video here and do try these questions. After all, practice makes perfect. And here are the answers. Don't get disheartened if you have made a mistake. Rather, take this as a learning opportunity and try to find out where you went wrong. Did you make a mistake when writing out the place values? Was your writing too crammed and you misread the place value or attached the wrong place value to a digit? Did you copy down the place values wrong in your sum? Or did you mess up the addition? If you know where you are likely to go wrong, you can start paying attention to those steps and correct them. Remember, every one of us had to learn these things, and we also made mistakes. It is all a natural part of learning. In the next part of this video, I would like you to use your own words and write down a step-by-step process for converting binary numbers to decimal numbers. Try to be short, concise, but precise at the same time, so there are no ambiguities and someone who didn't watch these videos would still be able to follow your instructions and get the correct answer for the conversion. I know this is hard if this is the first time you are doing this kind of work, but trust me, practicing this way of thinking will immensely help you with your programming. Pause here again and give this exercise a try. I will show you my version too. So here is my version. I am 100% sure your version is different, but as long as you followed the same order of steps and your description is clear and concise, you did well. If you missed out a step or mixed up some of the steps, or one of your steps just isn't clear enough, don't lose faith. Try fixing your version or write out a new one. And most importantly, make sure you write this method onto one of your flashcards and regularly test yourself on it. Also, do more practice questions. Having done a few calculations will help you grasp the method and be able to do some of the calculations correctly, but true mastery comes from repeated long-term practice. And believe me, by the exam comes, you will agree with me that binary numbers are boring in a sense that there is a straightforward method for every calculation, and if you know how to do them, they become quick wins on the exam. So, let us summarize what we covered in this video. First, we reviewed the binary to decimal conversion using the place value table. Then, we established that we can just pick out the place values with a 1 under them and add them together to find the decimal value of the binary number. Then we remembered that in the binary place values, every place value is the double of the 1 to the right of it. Or, if we start with the rightmost digit and use the smallest place value 1, we can find the rest of the place values by doubling digit by digit until we reach the leftmost digit. You had a chance to apply this method to a few questions, and in the last part of this video, we have written down a step-by-step method for this conversion. I hope you have found this video useful and that you like this shortcut method of binary to decimal conversion. In the next video, we will move on to converting decimal numbers to binary numbers. Until then, keep learning, one byte at a time.